start the last video for lesson 4, I just picked one of the fraction problems. We had one on the last page, page 1. This is page 2, by the way, and we have 3 on here. Like I said, I believe we're going to have 4 on the test. So just a refresher, since this came from the lesson before this one, it's been a little bit, been a minute. Remember, to clear the fractions, we find a number all the denominators go into. So the method I showed you was write the biggest denominator and start doing multiples. Does 4 go into 4? Yes. Does 2 go into 4? Yes. Boom! Already found your common denominator. And I'm just going to give you one more hint and I'll let you take it from here. Then we learned once you found your LCM, then you put it in the numerator of every fraction. And notice I rewrote my problem bigger so that I could fit this all in. So every numerator all the way down the line now has 4 in it. 4 times 4 times 4. And on the next step, you should have no fractions, and then you can continue to solve. Go ahead and work on that, and then come back and start the video, and we'll check it together. Okay, so this one is 12 divided by 4, or you could do this either way. 12 divided by 4 is 3. If you cancel the 4s, it's 3. So it doesn't matter which way you do it. So multiply and then divide, or divide right away, and we're left with 3x minus, this is 4 divided by 2. 4 divided by 2 is 2. And then 1 times 4 is 4. And look at that easy problem. So we went from this ugly mess into this pretty little 2-step problem. Love it. One of my very favorite things is getting rid of fractions and making this beautiful little problem. So to solve, we need everything without an x moved over to the right side, so do the opposite to get rid of it on the left, and we get 3x equals 6. Divide by 3, divide by 3, x equals 2. Actually, I should write it here first. Piece of cake, right? So we'll go ahead and continue to do these and then move down to the inequalities on another video. Okay, so we are on our last page of lesson 4. It's page 12 of your packet. We just finished page 11 in the previous video. We did some all real numbers and no solution problems at the end. So we have 5 more problems to finish off this lesson. So on these first 3, we're going to be solving what are called compound inequalities. One of them is already solved. Our goal is to get x alone in the middle. Not alone, not alone, alone. So we can go straight to the graph and the set builder notation and the interval notation. So this tells me to put a bracket at -2. So let's do -2, -1, and 0. Bracket at -2. And we know from lesson 1 and from the beginning of this lesson, this means x is in between -2 and 0, including -2. So the 0 gets a parenthesis because it has no equal sign, and we shade everything in between. I like these the best of all of them because they're the easiest to write your interval notation. You drop your two endpoints down, -2 gets a bracket, 0 gets a parenthesis, done. So these are super easy to write your interval notation because they're just the two endpoints, everything in between, and then be sure and do your correct symbols. So there wasn't any solving. There's the graph, the set builder notation, just to keep practicing. Do one more on this page. Look and see what variables used, x, such that, and then we just insert the answer straight in. And we know this is the answer because x is alone in the center. So there was no solving on this one. Nice and easy. Okay, for the next one, we got a little bit of work to do. So notice that compound inequalities have three sides. So when you go to move this one away from the 5x, you have to do it to the left side, to the middle, and to the right side. So instead of doing -1, -1, you have to go -1, -1, -1. Why am I doing -1? Because my goal is to get the x alone. So if you just had these two sides, wouldn't -1 be your first step? Well, with three sides, it's the same first step. So do the opposite. You need to move it out of the center, but now instead of just doing it on two sides, this is a three-sided inequality, so you have to do it to all three sides. And so then it turns into -25 is less than 5x, which is less than or equal to 6 minus 1, 5. So always be careful you copy those inequalities correctly so you get your parentheses and brackets right. So x isn't quite alone. I just keep doing this. Anytime I get confused, what would I do to solve this? Divide both sides by 5. I'm dividing by a positive, so I will not flip the symbols. So divide by 5 in the middle, divide by 5 on the left. Oh, don't ask me why I put that negative there. Divide by 5 on the right. So all the way across, do the same thing. -1, -1, -1. Divide by 5, divide by 5, divide by 5. Mission accomplished. We have our x alone in the center. That's our goal, is to get x alone. So a negative divided by a positive would be -5. We did not divide by a negative, so the symbol stays the same. And this would be 1x or just x. And then less than or equal to anything divided by itself is 1. So isn't that easy? I think they're easier than the ones on the last page, because now all I have to do is the graph, and the graph's a piece of cake. So -5, -4, -3, -2, -1, 0, 1. So I'm just going to label the endpoints. Maybe I'll label 0, 2. -5 gets a parenthesis. 1 gets a bracket. And because x is in the middle, that means the solutions are in between -5 and 1. So I shade everything in between -5 and 1. And then, like I said, interval notation's a piece of cake. Basically, you're just dropping your two endpoints down with their symbols. -5 on one end, parenthesis. Whoops, not -1. Wow, why do I keep adding these random negatives? +1 on the right with a bracket. Now that's going to bug me, so I'm like one of those anal people that always has liquid paper right beside them because I can't stand mistakes. So I got to take that out. Been in math too long, I guess. You get super anal. Okay, so I'm going to start you off on the last one, and then I'm going to let you take it from there. So the first thing I notice is fraction. No can do. Remember what I said. Anytime you have a fraction, step one, get rid of it. You should never have to solve a fraction equation or inequality again. So let's take this and make it a little larger since we're going to be multiplying. And I'm going to rewrite it as 2/5 x. Remember how on our same and different we said these are the same thing? Just kind of makes it easier. Okay, so you want to get rid of the fractions. So what's the common denominator? Well, there's only one. So that has to be the common denominator, 5. So then we multiply every term, and notice there are 1, 2, 3, 4 terms. So every one of those 4 terms needs to be multiplied by the LCM 5. And like I said, this is a huge concept in your next class. We have a whole chapter on clearing fractions. The only difference is the fractions are going to be quite a bit busier than these because they're going to have polynomials in the numerator and denominator instead of just numbers. But the technique's the same, so practicing clearing fractions, huge. Not only because you have it on your quizzes in this quiz in this chapter, you have it on your tests in this chapter, you have it on the final exam, but also because it's in the next class. Okay, I'll let you guys take it from there. And notice we're multiplying by a positive 5, so none of the symbols will change. So go ahead, shut off your video, finish solving that, and then turn it back on and we'll check how you did. Okay, -4 times 5 is -20, less than or equal to, and remember what I said, when these are the same, just get rid of them. Anything divided by itself is 1. So all I'm left with is 2x, don't lose that x, minus 5, less than 0 times anything is 0. And now I just have a nice simple 2-step problem. How do I know it's 2 steps? Because if I cover up this side, I can see it's add 5, divide by 2. The only thing different is we're going to be doing it to all 3 sides. So we need to get rid of everything inside so that the x is alone in the middle. So do the opposite of subtract 5, which is add 5. And that leaves us with -15 is less than or equal to 2x, which is less than 5. And so our last step is to divide everything by 2. It's a positive 2, so no symbols are going to flip. So that's going to leave us with -15/2 is less than or equal to, x is now all alone in the center, and 5/2 over here. So when you're graphing these, it is a little bit easier if you change them to decimals, just so you know where they're at on the graph. So this would be -7.5 if you typed it in your calculator, -15 divided by 2, and this would be 2.5. And that is a really teeny graph, so I'm going to make a bigger graph so we can get it on there. So -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. So there's 3 and there's -8. And then we'll put the 0 in, 2, 1, 0. So -7.5 And Alex does occasionally have you graph decimals and fractions, but if we left it as a fraction, it'd be hard to find where it goes to. So when you type it into Alex as your answer, you have to type it in like this. I just changed it to decimals to make it easier to graph. So negative 7.5 has a bracket. I'm going to do it in a different color just so we can see. So there's negative 7.5 right in the middle, and it's a bracket. And then label it with its real endpoint rather than the decimal. Positive 2.5 is going to have a parenthesis. So there's 2.5, and it's going to have a parenthesis and label it with its fractional answer. Because rarely will Alex ever ask you to change something to a decimal. And this is X is in between those two values. So to write our interval notation, we'd go bracket, negative 15 halves, which is on the left, comma, 5 halves is on the right, with a parenthesis. And there you have it. So even though it was fraction-y answers, still just as easy. So those are called solving compound inequalities. Okay. So our last two problems of the lesson are going to be word problems. Love, love, love word problems, especially the translation ones. We've worked so much on those. I think students are going to do great on the test. Twice a number subtracted from, ooh, there's that from again. Remember, that means the 35 must be first. So twice a number subtracted from 35 would look like this. 35 minus 2x. From 35 means 35 is first. Is greater than, so no equal sign, just the greater than 15. Find all the numbers that make this true. So basically, they're just asking us to solve. X's need to remain on the left. So anything without an X moves to the right. This is a positive 35, so we'll be subtracting 35 from both sides. Gone. Negative 2x is greater than, when the signs are different, we subtract. 5 minus 5 is 0. 3 minus 1 is 2. Keep the sign of the larger. And especially if you're on a test, you would definitely want to back that up with your work. 15 minus 35, just to make sure you got it right. Uh-oh, look what's going to happen. And you know I'm going to put these on the test. Oh, I wanted to highlight one. If you guys still have page 11 handy, that one that you guys did is a really good one to practice on. Did this one on your own. Example 4. This is similar to what I put on the test. Because I know I put one on the test where the symbol has to flip. You're dividing by a negative, flip the symbol. And it has parentheses in it, negative signs and stuff. So that's a really good one to study for your test. I would say if you can do that one, you can do any problem from this section. And since we're dividing by a negative, we immediately have to flip the symbol before we do anything else. Otherwise, you're going to get all involved in the signs and the division. You're going to forget. So flip the symbol first, then do double negative, make them both positive. So there are no negative signs left in this problem. So 2 divided by 2 is 1x, which is just x. Positive 20 divided by positive 2 is positive 10. So x is less than 10. And all it asks us is to find all the numbers that make this true. So pick any number less than 10, not equal to 10, less than 10, and it will be a solution to this equation. So negative 50, negative 10, 0, 1, 2, 8. Anything less than 10 works. I think this one is very similar to one that's on the test. I'm going to highlight this as well. I think both of these are, matter of fact. So that one, I know this one is on a quiz, but I think it's on the test too, and I believe this one is just like the one on the test. And you'll see we have some word problems on our practice test, and you'll see this one come into play. Okay, a couple will spend at most. Remember the little trick about at most? I had you write little notes on it on your earlier notes. We said at most means less than or equal to. And I said, if you don't remember that, at most 3,000s. That means they can spend 3,000 or 2,000 or 1,000. They can't go over 3,000. So that's why it's less than. So this is the one that I told you is always the opposite of what you think. And then we also did an at least in previous notes. And that means if I'm at least 30, I'm 30 or 31 or 32. So at least would be greater than or equal to. So this one's at most 3,000. So that would be less than or equal to 3,000. So we got that part of the problem done. If the catering company charges a one-time fee of $200 plus $32 per person, so just do it direct translation, plus 32 per person would be P. So P equals the number of people. So the minute I put a variable in an equation of a word problem, I need to write what P stands for. That's why I picked P. So P is the number of people. So 200 plus $32 times every person that comes to the event. So writing inequalities just as easy as writing an equation. Find the greatest number of people that can attend. So we're just solving our inequality just like before, and everything without a variable in it moves to the other side. So the opposite of plus 200 minus 200. So we get 32p is less than or equal to 2,800. Divide by 32, no flipping the symbol. Because we're dividing by a positive, we only flip the symbol when we divide by a negative. So 2,800 divided by 32, 2,800 divided by 32 gives us 87.5. I always hated these when I was in school because I'm like, oh, I don't know whether to pick 88 or 87. But then when I was teaching, I thought, oh, well, the symbol tells you it has to be less than 87.5. So you can't pick 88 because that would be your instinct, right? To want to round this to 88? No, this says less than 87.5. So we can only pick 87. So 87 people can attend if they want to keep their budget at 3,000 or less. And you could see where this would come into play if you had a child who was graduating or someone that was getting married, and they could use this formula to solve. Okay, I have $6,000 for my reception. I know they're charging $20 a plate and I have to pay a service fee of whatever, and you could do this exact same problem. So less than 87.5, we can't have 0.5 people, obviously. So I have to pick the number less than 87.5. That's why we get 87. I know you're dying to round it to 88, but that's greater than 87.5. So because of that symbol, we pick 87 instead of 88. So 87 people can attend for a budget of $3,000 or less, because that's what at most means. Okay, that is the official end of lesson 4. So I'll see you in the next lesson. Thank you.